Okay, so let's say now we want to convert numbers from decimal to binary, and we want to convert actually non-integer decimals from, or non-integer numbers from decimal to binary. So what do we do? So there's an easy way to do this. Let's start with a kind of like an easy example to do. Let's say I have 5.625, or let me even start with even a simpler one. We probably did that before. Let's say we start with 5.5. We said that the 5 is 101 in binary, and then the 0.5 was 1 over 2, right, which is 2 to the negative 1, which is basically the first digit to the right of the radix. So this becomes just 1. Now, this is a straightforward number, and we were able to kind of like guesstimate or guess how much was the fraction part of it. But what if it was something a little bit different? Let's say it was a 5.625, or what if it was like 5.2? How am I going to guess? Like what power is 2 4 to get 2? Well, we shouldn't guess. We should have a way to systematically calculate this. So the way we do it is assuming that we figured out this part already. So this is 101. I'm going to keep it to the side. The question is, how do I go about the 0.625? Well, the way we do it is we take the 0.625 and we multiply it by 2. The idea here is that we're going to repeatedly multiply the fractions by 2, record the answer that we get, and then repeat the process until we have no more fractions. If we continue to have fractions, then we have to stop at some point, which I'll talk about later. But the idea here is that we multiply the fractions by 2, and I record what value I get here. So like 0.625 is actually 1.25. Now, I'm going to keep track of the non-fraction digit that I got after I multiplied. So in this case, it's 1. So I'm going to keep track of that one. Then I take the remaining part, the remaining fractional part, and also multiply by 2. So I get 0.5. I keep track of this 0. Then I take this fraction part, 0.5. I multiply it by 2. I guess I did not multiply there by 2. I just wrote it. I mentioned it, and then I wrote it. So times 2, you get 0.5. So I need to keep track of this. And then 0.5, I take the fraction part here, I multiply it by 2, I get 1.0. Now, the fraction point here is not, like I'm done with the fraction, it's a 0, so I stop. So I have 3 digits here, I got my 1, 0, 1, which means 0.625 is actually equal to 101 in binary. So my 5.625 in decimal is 101.101 in binary. And if you want to double check this work, you can convert it back to decimal after you got it from binary. So this is 1 plus 4, that's a 5. And this is 0.5 plus 0.125, which is 5.625. So let's do another example. Let's say I have 0.6875. I'm going to rewrite it because it looks funny here. 6875. I want to convert this fraction from decimal to base 2. So, like I said, I multiply it by 2. I get 1.375. Now, like I said, I take the fraction part and I multiply it by 2. I get 0.75. I take 0.75, multiply it by 2. I get 1.5. Then I take 0.5, multiply by 2, I get 1.0. Now my fraction here is 0, so I stop, and the value I have is 1011. And the number then, if I want to write this in binary, so this number is 0.1011. You can double check again your work. 0.1 in binary is basically the 0.5. This is 2 to the negative 2, 3. This 1 over 8 plus 1 over 16. And that's equal to 0.6875. Now the question is, well, what if I have a non-terminating operation? What do I do with that? The answer is you basically need to know after how many times you need to stop. And sometimes that's dictated by how many bits you have to store the fraction part of the number. So let's take an example. So let's say I have 0.1 and I want to convert this from base 10 to base 2. Well, I only have the 0.1, so I take the fraction part and I multiply by 2, I get 0.2. Now 0.2 times 2 is 0.4, 0.4 times 2, 0.8, 0.8 times 2 is 1.6. Got this one. Now 0.6 times 2 is 1.2. Now if you notice that my fraction now is actually the 0.2 again, and if I take 0.2 multiply by 2, I get 0.4. 0.4 times 2, that's 0.8, and so on. So now you can see I'm going to repeat through another cycle. So I have 2, 4, 8, 2, 4, 8, and then I'm going to get a 6, right? 0.8 times 2 is 1.6, and so on. So this is a non-terminating value, and the first set that I got is essentially 0, 0, 0, 1, 1, and then it's going to repeat. This is base 2, right? So, and this is going to repeat over and over again. So the question is, like, after how many trials do you stop? Well, it depends on how many bits you have allocated for the fraction part of your number. Well, how many bits do I have? This is what we're going to talk about next, in terms of how do you represent fraction or non-integer numbers in binary. That's what we've been doing so far. We're converting numbers from decimal to binary and binary to decimal, but now we need to save them in memory. And I need to know like how many bits I have to represent these numbers. So I'll cover that in the next video. Thank you for watching this one. I'll see you in a minute.